So let's take a look at this problem. It was question 13.7 part E that we talked about in class yesterday, and there seemed to be a little bit of confusion as to how this reaction works. So you can see from this reaction here that we're adding, we're generating an alcohol from an alkene. So this is an addition reaction, and you can see very clearly that this is a Markovnikov addition. So Markovnikov addition. So now that we have a Markovnikov addition, there's two kinds of conditions that we've looked at, or that you would have looked at last semester. And one of the conditions was just using dilute sulfuric acid. So those were one of the conditions. And the other condition that we talked about in class, and you would have learned last semester, was to, and the first step is to use mercuric acetate and water. And then the second step is to use sodium borohydride to do what's called a demercuration. So these are your two options. You have two options to do this, or you ask yourself, which one of these? So which one of these two options should I use? Should I use option A or option B? Well, let's look. I mean, yesterday we talked about sulfuric acid. It's a lot easier to work with than working with mercury, which is a toxic compound. So why wouldn't we want to use dilute sulfuric acid? So if you use dilute sulfuric acid, you're going to have hydronium ions in solution. So instead of drawing H+, I will actually draw this out. So what's going to happen is those electrons in this alkene are going to pull off that proton, and what you're going to end up with is something like this, where you have this compound here. So you added your hydrogen on this carbon here, so now you have CH3 out here, and you have a hydrogen where the positive charges, I'm not including that one, but this is a secondary carbocation. So what's interesting about this particular molecule is that if you look at it really closely, that we have a secondary carbocation here, but what if this methyl group were to just do a methyl shift and move over one carbon? Then what are we going to have? We're going to have, let me go back to my red here, we're going to have this compound, and our positive charge is going to be over here, and this is a tertiary carbocation. So since a tertiary carbocation is more stable when water adds to that, so when we have water adding to that, and I'm not going to draw out all the details, if you lose a proton, after this the water's going to add, then two, you're going to lose H+, and what you're going to end up with as a product is you're going to end up with this. And this is not the desired compound. This is not what we're looking for. So you can see that when you use dilute sulfuric acid here, you're going to end up with a carbocation rearrangement to generate this more stable tertiary carbocation, and you're going to end up with the wrong product. So if you chose this as your reagent, it's going to give you the wrong product. So the reason that we learn about oxymercuration, demercuration, is because, let me redraw these things out here just so we get the 30,000 foot view of the whole thing here. So if we redraw this out, so we make this look all beautiful. So we have our alkene. If we use the reagents, if we use mercuric acetate and water, that does our oxymercuration, and demercuration is done by using sodium borohydride. We're going to get that Markovnikov addition. So we're going to get our desired product, but we are going to avoid any kind of carbocation rearrangement. So we're going to avoid carbocation rearrangement. And this is something you're going to have to recognize. You're going to have to understand when you would choose sulfuric acid, dilute sulfuric acid, and when you would choose oxymercuration, demercuration as the way to add across a double bond to generate an alcohol and do this Markovnikov addition. So that is why we choose mercuric acetate and water and then sodium borohydride, and we do not use, let me just emphasize this, we would not use, I'll say dilute sulfuric acid. We would not use that. So I hope that clears up any confusion about this question that we talked about yesterday in class.